All right, back at it with part 2, number 17 here. So 3 dice are tossed up at exactly the same time. Jose wins if he gets a sum less than or equal to 16. What's the probability that he wins? Okay, well, we're going to have to do the probability of 1 minus not getting something less than or equal to 16. So if you're rolling 3 dice, 6, 6, and a 6, 18 is the highest that you can get. And you could also get a 17, and I can say I get a 5, 6, 6, a 6, 5, 6, and a 6, 6, 5. These are all equal to 17. Does this fit this sentence here that it has to be a sum less than or equal to 16? Is 17 and 18, is it less than or equal to 16? No, they're not. And so those are in our complement, meaning the not. So the probability of this happening less than or equal to 16 is 1 minus the probability of it not happening. Well, that would be the probability of getting a 17 or an 18. And the probability of getting a 17 or an 18 is 4 out of how many? Well, we got 4 out of how many? Well, if you're rolling a die 3 times, if we do the counting principle, we're going to have 3 slots. The first option, you got 6. Then the second, you got 6. And then you got another 6. 6 times 6 times 6 is equal to 216. Okay, so this is going to be equal to 1 minus the probability of getting a 17 or 18. Well, that's going to be 4 out of 216. So it's going to be 216 over 216 minus 4 over 216 is equal to 212 over 216, which does in fact reduce to 98.14%. You could just say 98.1%. I don't care how you answer. You could have reduced that as a lower fraction as well. Doesn't matter. All right, there's a 40% chance that Marco hits a bullseye when he throws. Using the binomial distribution table, what's the probability he makes at least 4? Well, you could, if you wanted to, you could go to your 40%, and at least 4 means you would be adding up all of these numbers because you're trying to get at least 4 or more really. So you could add up all those numbers and that gives you your answer. I kind of feel like it's easier to do 1 minus the probability of not doing that, which would be the probability of getting less than 3. And so I add up actually all these numbers, and that gives me 1 minus 0.003 plus 0.015 plus 0.047. So that's... And that gives me 0.935. Sorry about that. Can't get rid of it, which is roughly 93.5%. And if you had added up these numbers here, you'd either get exactly that number or maybe slightly off, just because these are rounded decimals. All right, number 19, you pick 2 chocolates from Miss Sorensen's box of chocolates. Let C represent the number of coconut-centered chocolates that you pick, and create a probability distribution table for C. And we can leave our answers as decimals. So if we pick 2 chocolates, we could either get 0 with coconut centers, 1 with a coconut center, or 2 with a coconut center. So 0 with a coconut center would actually be the same thing as getting no coconut, no coconut. Well, there were 17 no coconuts out of 20, and then we'd pick 1 no coconut, we're left with 16 over 19. And this does give me 0.715789. Then I like to go to number 2 here. What's the probability of getting 2 coconut? Well, that would be 3 out of 20 and then 2 out of 19. And if you forgot about these numbers, you can go back to the previous problem. It told you about that. All right, and then what I would do is just do 1 minus adding up the 0.715789 and the 0.01578, because remember, these are supposed to add up to 1. And that gives you 0.268421. If you don't like that method, you could go ahead and you could find the probability of getting coconut and then a no coconut, and then a probability of getting a no coconut and then a coconut, and then adding those, and that gives you your answer to number 1. All right, number 20. During the 3 days of the Memorial Weekend, there's a 30% chance each day of getting rain. Make a probability distribution table for R, the number of days receiving rain, and you don't need to simplify, but you do need to use combinations. I like to immediately write down that 0.3 is equal to rain and 0.7 is equal to no rain, because I feel like most mistakes happen by confusing those two numbers. Okay, we're talking about 3 days, and so we can have 0 days of rain, 1 day of rain, 2 days of rain, or 3 days of rain. I can't get rid of those dots. I did it. All right, well, what's the probability of having 0 days of rain? Well, that's going to be 0.7 to the 3, right? Because 0.7 represents no rain, so we want 3 days of no rain, and then we'll have 0.3 to the 0. Okay, then here we're going to have 1 day of rain, so it's actually going to be 0.7 to the 2 times 0.3 to the 1. And then we need to choose 1 day. So out of the 3 days, we want to choose 1 day to have rain. Okay, so that's part of that. And if you wanted to, you could have had 3 choose 0 here, but really that's 1, so who cares. Okay, this next one, you can start to see the pattern. We're going to have 1 day of no rain times 0.3, and that's going to be 2 days there. Sorry, these look kind of confusing. I'm just going to change them to that. And then here we're now down to 0 days of no rain, and then our 0.3 is our rain days, so that goes to 3. And then just kind of follow this pattern. We're choosing 2 days to have rain there, and then we're choosing 3 days here. And that's it. All right, number 21, Mr. Mumley decides to do a raffle, and he wants to raise money for the soccer team. Nice guy, eh? He sells 2,000 tickets for $10 each. And the first place prize is $4, second place prize is $2,000, and then there's 3 third place winners. What's the expected value if you purchase 1 ticket? Okay, so we need to set up our V, our P for probability, our V times P, and then we'll add those all up. So the first value is getting $4,000, then you get $2,000 for second, and then you get $500. And since they're selling 2,000 tickets, the probability of winning first place is 1 in 2,000. Then second place is 1 in 2,000, assuming that tickets get put back in. And there's 3 winners for third place, so the probability of winning that is 3 out of 2,000. So V times P is just multiplying this, and this is going to be 4,000 over 2,000. This is going to be 2,000 over 2,000. And then this is going to be 500 over 2,000. And then I want to sum up the V times the P. So I need to add up all of these. And since they all have the same denominator, I'm keeping that as 2,000, but then adding up the numerators, and I get 7,500. And this actually equals $3.75. And remember, how much did we pay? We paid $10 for the tickets, so we have to subtract $10, and that's going to give us negative $6.25. So our expected value is that we're going to lose $6.25. What's the cost of the ticket that would make this fair? Well, it would be exactly $3.75, because then we would have an expected value of 0, meaning we're not really losing anything. But do we want the raffle to be fair? Does Mr. Mumley? No, because he wouldn't make any money. Okay, number 22, for the binomial distribution in number 20, find the expected value and the standard deviation for the number of rainy days. So let's go back to that question. Where my rainy day question? Oh, rainy day. I think I went too far, didn't I? I think it was this one right here, right? 30% chance of rain and 70% chance of no rain. So, and we're talking about 3 days. So our expected value formula is equal to N times P, where N is 3 days and P is the probability. In this case, the probability of rain was 0.3 or 30%. So we expect 0.9 days of rain. That's our expected value. And remember, that's out of 3 days. All right, now what's our standard deviation? That's going to be equal to the square root of n times p times q, where our n is still 3, our p is still 0.3, and then our q is, in this case, the no rain, the complement of rain. And these numbers should add up to 1 always, so this is going to be times 0.7. And that's going to give me 0.7937 days, meaning we should expect the majority of the time we're going to be within 0.7937 days of that expected value. All right, folks, that's it. I hope you're having a great day. Good luck on the quiz.